Hey you guys, today we're going to work with section 2.4 on deductive reasoning. We already covered inductive reasoning, which is where you looked at a pattern and to guess what came next to find your conclusion. Deductive reasoning is a process of logical reasoning from given facts. So there's the key thing here, is that it all deals with facts, not patterns. Patterns can not always be right, but facts are always right. So with deductive reasoning, we're going to look based things that are on truths and make sure that they are correct. With deductive reasoning, we have two laws. Our first law is called our law of detachment. And our law of detachment says if the hypothesis of a true conditional is true, then the conclusion is true. So if we have a true if P then Q statement and P comes true, then we automatically know that Q will come true as well. So let's look at this statement. If a student gets an A on her final exam, then this student will pass the course. Felicia got an A on her history final exam. So let's break this down. First thing, identify your hypothesis and your conclusion. So our hypothesis is a student gets an A on a final exam. Our conclusion, the student will pass the course. So what you want to check is look at the second statement you're given and does it match your hypothesis of the conditional. So our second statement is that Felicia got an A on her history final exam. And if we look, that does match our hypothesis that a student gets an A. So since we have a true if-then statement, our hypothesis came true, that tells us that our conclusion will come true. So the second statement matches our hypothesis. So by the law of detachment, you can make the conclusion. Our conclusion is that Felicia will pass her history course. Let's look at example B. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. So let's break this down into our hypothesis and our conclusion. Our hypothesis is a ray divides an angle into two congruent angles. Our conclusion is the ray is an angle bisector. So let's look at our second statement and see if it matches our hypothesis. Our second statement is ray RS divides angle ARB, so that angle ARS is congruent to angle SRB. Well, yeah, that matches. A ray divides an angle into two congruent angles. So our hypothesis matches, which lets us know that our second statement matches our hypothesis. We can conclude that ray RS is an angle bisector. Now, let's look at example C. If two angles are adjacent, then they share a common vertex. Well, angle 1 and angle 2 share a common vertex. So again, break it down to your hypothesis and conclusion. Our hypothesis is two angles are adjacent. Our conclusion is they share a common vertex. So again, look at our second statement. Does it match our hypothesis? Angle 1 and angle 2 share a common vertex does not match the hypothesis. It matches the conclusion. So that lets us know we cannot make a conclusion here. Using our law of detachment says you have to know that the hypothesis is true, then the conclusion is true. You cannot work backwards. You cannot say our conclusion is true, so our hypothesis is true, which means we can't always do our converse here. Our second law is called the law of syllogism. And the law of syllogism says if we have if P then Q is true, and then Q then R is true, we can conclude that P then R is true. So like here's an example. If it is July, then you're on summer vacation. If you're on summer vacation, then you work at a smoothie shop. So our final conclusion is if it's July, then you work at a smoothie shop. Because what this is saying is that we have our first P here. It is July. And our conclusion is you're on summer vacation. Our conclusion repeats as our new hypothesis. You are on summer vacation. We have a new conclusion. You are at work at a smoothie shop. So the law of syllogism says we can go from our very beginning, if it is July, to the very end, then you work at a smoothie shop. You can skip the stuff in the middle. Now, the direct TV commercials are fantastic examples of our law of syllogism. So I just pulled one up on YouTube so that we could look at it and you could see like how these work.
When you get bored, you start staring out windows. When you start staring out windows, you see things you shouldn't see. When you see things you shouldn't see, you need to vanish. When you need to vanish, you fake your own death. When you fake your own death, you dye your eyebrows. And when you dye your eyebrows, you attend your own funeral as a guy named Phil Shifley. Don't attend your own funeral as a guy named Phil Shifley. Get rid of cable and upgrade to DirecTV. Call 1-800-DirecTV.
Okay, so that's just like a cute example of how you can use your law of syllogism, okay? So let's look at some that we have to do with our math. If a figure is a square, then the figure is a rectangle. If the figure is a rectangle, then the figure has 4 sides. So let's break this down to our P. If a figure is a square, our Q is the figure is a rectangle. We need our Q to repeat. A figure is a rectangle, and now we have our R statement. The figure has 4 sides. So the first conclusion of the first statement is the hypothesis of the second statement. Basically, our blues match. So you can use our law of syllogism. Our final conclusion is if a figure is a square, then the figure has 4 sides. Let's look at example B. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. So let's break it down. Our P, you do gymnastics. Our Q, you are flexible. Well, look at our next sentence. You do ballet is our R, and then we have our Q for you are flexible. So did this go in the correct order in order to be our law of syllogism? So the statements have the same conclusion. Neither conclusion is the hypothesis, meaning you are flexible never came back to be our hypothesis. So we cannot use our law of syllogism here. These statements have no conclusion. So you can't tell me anything about this. You don't know anything about gymnastics and ballet. Don't know anything about being flexible. Sorry. Last one. What can you conclude from this given information? If you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. Asia lives in Accra. So let's figure this out. Identify your hypothesis and conclusion of each statement. So our hypothesis is you live in Accra. Conclusion, you live in Ghana. Now this repeats. You live in Ghana. So conclusion, you live in Africa. All right, let's break this down. We can use our law of syllogism to decide that if you live in Accra, then you live in Africa. We're taking our blue statement out and just going straight from our beginning to our end. Next, you can use your new conditional statement, the fact that Aisa lives in Accra, and the law of detachment to make a conclusion. So, since we have that Aisa lives in Accra, we can substitute that in. We now know that Aisa lives in Africa. So our final conclusion from all of this information is we know that Aisa now lives in Africa. Alright, that's it for our 2 laws, our law of detachment and our law of syllogism. Talk to you guys later.